Right, in this video, I'm just going to take a look at one of each of these graphs just to give you a refresher of what you can do and also some stuff you can use in the calculator. Everybody probably had different teachers for this topic, so you can do it the way that you remember and also use the calculator now. So if you're looking at transformations, I'm going to look at number 5 here. This has a reflect over the x-axis. And then it goes left 3 and down 2. And that kind of helps you with one of the particular points on there just to kind of get an idea of what's happening. Since this is exponential, the down 2 is going to tell you where your asymptote line is going. So I'm just going to put a dashed line going across at -2. That's going to be important for your range. Just slide this down. So our domain is always going to be -infinity to infinity for this, and the range is what's going to vary. We have y equals -2 for the horizontal asymptote. So some of these key things are the important things that we just want to refresh with the graphing. We're mainly going to be looking at the algebraic stuff. And then we're not going to have an x-intercept because it's going to be facing down. And we're going to be going -infinity to -2, or you could graph it first to see that. So in fact, we could go over to the calculator and we can plug that in. And then get some good stuff from your table. So just usually get a couple points that will fit on the graph from there. Now that we have this as an option, I just blocked that out, but I have them written down, so. Usually a lot of these grids will go to 10. I don't know if this one does. 1, 2, 3. It does. So we can plot these points just to get an idea of the shape of the graph, to see that it's getting closer to that asymptote line. And it doesn't matter to me how many of these points you do have on there, as long as you get that general shape at this point. And then we can see that our y-intercept is 0, -10, and you can find that by scrolling down to the 0, or you can plug in 0 into the x, calculate that, and that would also give you -10. Okay, so that's one of the exponential graphs. Again, all the other ones are kind of similar. So let's take a look at one of your log graphs. The first is just matching, I think. Doesn't really matter. Let's do 5 again, just so it has enough information in it. Now this has some different information and things that you're going to be finding. So now it's our range that's -infinity to infinity, flip-flops, because the log is the inverse function. And then the domain is going to come from taking that parentheses and making it greater than 0. So normally you have an asymptote at x equals 0. It's now going to change. In this case, we would have greater than 1. So x is greater than 1/2. You can actually write your domain that way. I know a lot of us like the interval notation, so I'm going to do 1/2 to infinity because it's going to be positive. Again, you can wait and see what happens with the graph. And then I'm going to actually just go on these graphs every 2. So I can plot the 1/2 a little bit easier. You don't have to do that. Just for this one, I think that's a good idea. So I'm going to, again, do a dashed line, but at x equals 1/2. A little dicey down there. So that is our vertical asymptote. So again, for this one, it's the domain, the vertical asymptote. Those are some of your important key information pieces here. And then we can grab some points from the table. Now, as long as you have an updated calculator, you can do log base. And there's 2 ways to get it. You could go to math, or you can hit alpha window. Alpha window has a couple shortcuts, and if you select log base, it puts the base in there for you. And then 2x minus 1 plus 1. And then we can go to the table, We see a lot of error messages, so those aren't points. And then you can just pick a few points to plot. So 1, 1, 2, 2.6, 3, 3.3, that should be enough just to kind of see what's happening. And then the x-intercept you're going to get by doing the following. Set your equation equal to 0. Since I'm not doing all of these, I'm kind of encroaching on some extra space here that I have on the side. You want to get the logarithm by itself, so subtract, divide, whatever you need to do, and then switch to exponential form once you have that. And then we're just solving this for x, so do 2 to the negative 1 plus 1 divided by 2. This is going to give you x is 0.75 or 3/4 depending on what you do with your fraction stuff. So this would be 0.75, comma 0. There is no y-intercept because we had the error message there, but I would still use the table for the y-intercept. And then just one other thing, if you don't have the option to use the log base, you can use the change of base formula. So you could do log 2x minus 1 divided by log 2. And then add the 1 there. It's going to give you the same information. You can see when you compare it. But that's another way to type it in the calculator. And then for exponentials and for the logs, we also have, if you look at example 6, the ln. So just remember your ln button is here. Sorry, clear this out. This would be your ln if you're trying to type in the ln, which is actually easier than log base. That's just log with base e. All of the values in the table you're going to get will be decimals. And then when you're solving for the x-intercept for this, I would make this into log base e of 4 minus x equals 0. And then you're going to, this would cancel anyway, so e to the 0 equals 4 minus x, and then you could finish solving that. And you do have an e button. You have two options. You can do second e, or second ln, which gives you e to the x, or you could do second division sign, which gives you the e. I don't actually want to type that in because it's going to make a mess there. Okay, so just two quick refreshers on how to do the graphing with some added bonuses of how to use the calculator if you weren't familiar with that already. But most of this should be review. Again, focusing on understanding your domain and range and your different asymptotes for the two different types of graphs when you're doing the practice.